Hi, this is Mrs. Basin, and this is the Limiting Reactants Practice Quiz. So when we do one of these problems, the first thing that you're going to get is the reaction. So before you can do any calculations, you have to come up with the balance equation. So in this particular reaction, we have aluminum reacting with oxygen in a synthesis reaction. So what that means is we're going to have aluminum plus O2 giving us aluminum oxide, since it's synthesis, which is going to be Al2O3 when we cross our charges. So then, because of that, we're going to have to balance this. So this ends up being 4, 3, 2. So 4Al plus 3O2 gives us 2Al2O3. So then our next step is to look at what amounts of reactants are given. So this particular reaction tells us there's 3.17 grams of aluminum and 2.55 grams of oxygen, and we want to know which reactant is limiting. So since they give us amounts of both, we have to run both of those through a stoichiometry problem to figure out which one makes less. The one that makes less product is the one that is our limiting reactant. Now, if there had been more than one product for this particular reaction, you could run both of those to the same product, and it wouldn't matter which one. But this particular one, since we only have one product, we're going to take each of those to the same, to the product that was given, which is aluminum oxide. So we're going to start one problem out with 3.17 grams of Al. And then our second problem will start in a minute with our 2.55 grams of O2. So this one, we're going to first convert grams to moles. So we're going to use a molar mass. So 1 mole of Al is 26.98 grams of Al. Then our next step will be to do our mole ratio. So we're looking at moles of Al to moles of Al2O3. We want moles of Al to cancel, so I'm going to put my 4 moles of Al on the bottom, and again that number comes from the coefficient in my balanced equation, to 2 moles of Al2O3. So then my last step will be to go back to grams of Al2O3. So 1 mole goes on the bottom of Al2O3. And my molar mass of Al2O3 goes on the top, and that is 101.96 grams. Okay, so then after I have that set up, I'm going to go through and I'm going to do my calculation. So that comes out to be 5.99 grams of Al2O3. So that's my first problem. So now I'm going to do the same thing again, only this time I'm going to start with my amount of the other reactant. So this time I'm going to go to the same product. I'm still going to go to Al2O3, but this time I'm going to start with my 2.55 grams of O2. And again, my goal here is to find out which one of these makes less, and that lets me know what's going to run out. So I'm going to start it out the same way, but this time changing to moles of O2 because that's what I started with. So that's 32 grams of O2 because it's diatomic. Next step, go to my 2 moles of Al2O4. But this time, since I'm going to O2, my ratio is 2 to 3. So 2 moles of O2. And then last step, I'm still going to go back to grams of aluminum oxide. And then finally, I'm going to do my calculation. So for this reaction, it gives me 5.42 grams of Al2O3. So what that tells me is if I start with my oxygen, it makes less product. So from all of that, I can determine that oxygen is my limiting reactant. So then what that tells me is whatever I started with, so this one right here, oxygen is limiting because it made less product. Okay, so then I'm going to cross out this one. So I'm going to go back to my original equation just so I can label things so I remember when I do all the rest of these problems later on. So again, what this tells me is oxygen is limiting, so I'm going to put an L there, which tells me that aluminum is my excess. So oxygen limiting, aluminum excess, and again, that's because when I ran those two problems, when I did the problem with the oxygen, it made less, and that tells me that the oxygen would run out first. So then if I look at my next problem here, how many grams of aluminum oxide are formed? All I have to look at is what I just calculated. So what I just found out in my previous problem is I could make 5.42 grams of aluminum oxide. So that problem was already done for me. My next step then is I want to know how much of the limiting reactant is left over. So for this one, by definition, limiting means it's going to run out. So when the reaction stops, there are 0 grams of limiting reactant remaining. So it doesn't matter what the limiting reactant is. If the question says how much of the limiting is left over, the answer is always going to be 0 grams because the limiting reactant is what runs out and stops the reaction. Now usually another question you're going to be asked is how much of the excess is left over. So in this case, we want to know how much aluminum is left over. So to find that out, we have to figure out how much aluminum was used. So to do that, we're going to go back and we're going to start with our limiting reactant. So I have 2.55 grams of O2. And the reason I'm starting with my limiting is because that is the one that's going to run out. So that determines how much of everything else can be made or used. So I'm going to go from limiting this time to excess to find out how much is used. So first step, change that to moles. So moles of O2 to grams of O2. And like I said, this time I'm going from limiting to excess. So instead of going to a product like I did up above, this time I'm going to go to my other reactant. So my ratio between the two is 4 moles of Al to 3 moles of O2. And then my last step, just like always, to go back to grams. So 1 mole of Al is 26.98 grams of Al. Then I'm going to do my calculation. And this tells me that I used 2.87 grams of Al. And again, that's how much is used. Okay, so if the question says how much is left over, I have to subtract how much was used from my original amount of aluminum. So the number that you use should always be less than that number you started with. So to find out how much is used, I have to take, and I'm going to do this problem up here, 3.17 grams minus 2.87 grams. So when I subtract those, I have 0.3 grams of Al left. So this is my final answer to that last problem. Okay, so one more time to kind of go through, if you want to listen to it one more time. First thing I have to do is come up with my balance equation. So that's what I did at my tab. The top, I'm going to change color here so we can kind of go through this step at a time. So first thing is I figured out my balanced equation. So that was my first step. Once I have a balanced equation, I'm going to take both of the reactants and run them to the same product in a stoichiometry problem. And my goal is to find out which of those starting reactants made less product. So when I did that, I realized that starting with oxygen made less product, so 5.42 is less than 5.99. So what that told me was the number I started with, or the substance that I started with, was my limiting reactant, and that's the one that's going to run out. So since that's the one that's going to run out, my answer to that problem tells me how much of that substance I actually made. For the next part, how much of the limiting is left, the answer to that, again, is always going to be 0 because the limiting runs out, and when it runs out, the reaction stops. So by definition, the answer to how much limiting is left after the reaction is complete is always going to be 0. The final question is to figure out how much of the excess reactant is left over. To find that, you need to go from limiting to excess. So for this one, I went from oxygen to aluminum to find out how much aluminum was used in the reaction, then subtracted from the original amount to find out how much was left. So again, I started with my limiting reactant and I ran it to aluminum. What I found out was there was 2.87 grams of aluminum used, but I want to know how much was remaining or left. So I had to go back to my original amount of aluminum, which I did right here, subtract how much was used, and I found that there was 0.3 grams of aluminum left after the reaction was over. Finally, the last thing we can do, which I don't have on here is we could figure out a percent yield. So for the last problem or the last step of one of these, what you could do if you have a percent yield, they would give you the amount that you produced in the lab, and then you would, so for example up here, if we had to do this, percent yield equals actual over theoretical times 100. So the actual would be given in the problem. This number down here, the one that you calculated, that's your theoretical yield. So that's the number that would go on the bottom. The actual yield would be the one given in the problem, saying that this is how much you actually produced, what was your percent yield. So you're comparing that to your theoretical yield, which you calculated, times 100 to give you your percent.